Hello and welcome to the Data Engineering Podcast, the show about modern data management. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst is an end-to-end data lakehouse platform built on Trino, the query engine Apache Iceberg was designed for. Starburst has complete support for all table formats including Apache Iceberg, Hive, and Delta Lake. And Starburst is trusted by teams of all sizes, including Comcast and DoorDash. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst today and get $500 in credits to try Starburst Galaxy, the easiest and fastest way to get started using Trino. Your host is Tobias Macey, and today I'm interviewing Nikita Shamgunov about his work on making Postgres a serverless database at Neon. So Nikita, can you start by introducing yourself?
Great being here. My name is Nikita. I'm working, like you said, on serverless Postgres. It's been a very fun journey. We started 3 years ago and change on March 1st, 2021 with 3 guys and a slide deck. And now Neon is a company with 100 people and hundreds of thousands of databases under management.
And do you remember how you first got started working in data?
Yes. I think I always was fascinated with databases. I started to use PHP MySQL while still going to college because I was kind of moonlighting and trying to make a little bit of money while studying computer science back home in Russia. And then my first real job, like real job, was at SQL Server, which is a flagship database product at Microsoft. Before I joined there, I had no idea how large-scale systems are being built. And I really cut my teeth on database architecture, fundamentals, how to get quality at SQL Server. So that was my first intro.
Now, in terms of the Neon project, can you give a bit of an overview about what it is that you're building and some of the story behind how it came to be and why you decided that you wanted to spend your time and focus on it?
I actually thought about Neon while working on SingleStore, my previous company. And SingleStore was designed to be a scale-out system. And we had a very ambitious vision of becoming the system that can run both transactional workloads and analytical workloads in all kind of globally distributed system. Lots of learning certainly on that project. And then at some point, I was seeing the rise of Postgres because every single customer of SingleStore, and we had very large customers, had Postgres somewhere, right? They would put some like really large scale workload, usually either an analytical workload or a real-time analytics workload on SingleStore. And a part of the data feed that was going into that would always come from Postgres. And so I was just seeing Postgres everywhere. Also at the same time, my prior mentor at SQL Server, whose name is Alex Verbitsky, was telling me about this exciting project that he was working on inside AWS. That project eventually launched and became AWS Aurora. And I saw a very, very fast growth of adoption of Aurora. And with SingleStore, every time we would go into like application migrations, that was frankly a shit show, right? Because you have an application built against one engine, and then you're trying to, move the application from one engine to another. Turns out there's all these little quirks that prevent you from moving the application over. And then when, Aurora came out and I read about the architecture, I was like, wow, that's an interesting proposition. You don't lose the surface area at all. The surface area is exactly the same of the database product, but you have these additional benefits that you get through the separation of storage and compute. So, and then I started thinking about it, and I couldn't stop thinking about it. That was an interesting artifact of me. Obviously, I was running a company, and I didn't have that much time to build a side project there, and it didn't make sense to do it inside SingleStore. But I just couldn't stop thinking about it, and I spent many years in that idea maze where I was like, well, if I were to build a competitor to Aurora, what am I going to do exactly? How can I take advantage of open source? How can you take advantage of cloud distributions? What does it mean to be a developer versus infrastructure offering? When I left SingleStore, I joined Coastal Ventures. By that time, the idea was more or less formed in my head. up to a point, enough of a point to start a company, and certainly not enough to, fully plot the future path of how this is going to be successful. And walking in, I told Vinod Khosla, who runs Khosla Ventures and the founder of Khosla Ventures, that I have this idea in me. What do you think? Maybe we can prototype it. And Vinod is, yeah, for sure. We absolutely need to incubate it. How much money do we need? And I said 10 million. And he said, here is 5. So we got to work. And in this company, we engineered the team. One thing, you'll learn a bunch of stuff in venture as well. And one of the things Vinod always says is the team you build is the company you build. And in a way, I started to think about Neon not in terms of the plan, but in terms of the team. Who do you have on the team? Who do you need on the team? Defines what actually the plan is going to be and what kind of product this is going to become. And so this company was engineered around people who are very Postgres native, because I knew for sure, I knew 100% that if you diverge and you're not Postgres anymore, you use something else, Yugabyte, PlanetScale, CockroachDB, whatever that might be. Doesn't matter if you speak Postgres protocol. You're either Postgres or you're not. And so this company was built around people who contribute to the core Postgres engine. Heikki Leena-Kangas is a Postgres committer, and Stas was a Postgres contributor. So that became the foundation of Neon. Then, in the beginning, the only insight was that every successful cloud product inside a hyperscaler has an open source alternative, and lots and lots of examples of that. Right? For Redshift, that would probably be ClickHouse now these days. That's one of the more, or DuckDB, one of the more popular open source products. But then also Redshift had an alternative, a cloud native alternative, which is Snowflake, and Snowflake frankly out executed Redshift. So unbundling a popular database service seems like a good idea. And I was also thinking about GitHub versus GitLab analogy, where GitHub is a cloud product and GitLab is an open source product. And when you're an open source product, that gives you the right to exist. And I was like, nobody is building an alternative to Aurora. And that was strange to me. I even reached out to Alex and said, why don't we, Alex Verbitsky, who, in the first few years wrote the most code on that project, it's like, why don't we incubate this thing together? But Alex wanted to stay at Amazon, and I couldn't find other folks that would do a great job on it. And so I couldn't stop thinking about it. And so eventually we thought about, okay, we're going to just launch an open source Aurora. But then it was also obvious that the money is in the cloud, and building a cloud only product is what creates a lot more focus, as opposed to creating a cloud product and an on-prem product. So what we did is we kind of claimed our open source real estate by announcing to the world that, hey, this is this code base, and this is open source Aurora, or an open source alternative to Aurora, and the code is open, and the code is under a good license. So, anybody can watch it, anybody can adopt it. But we only focused on building a cloud product that consumes this code, but delivers this as a service. So that was kind of the second insight. And that was the plan from the start, to only be a cloud product. The third and the fourth insight came as we started working on that. I learned that, there's lots of things you can do with the database technology. You can work on mega resiliency for, multi-region deployment. You can work on multi-master, increase write throughput, because, database kind of bottlenecked on the amount of writes you can send through them today. You can work on analytics. And what would be this defining feature of your product vis-a-vis what you can get off the shelf from Amazon? And then we realized that serverless was kind of a big deal. And that's when we made a decision to delay our release, and it delayed our release by at least 6 months, and ship it serverless only. And that word only is something that I learned competing with Snowflake, where frankly, single store did too much. We did cloud and on-prem, we OLTP and analytics, and that prevented us from like truly competing for what became a big category, right? Data analytics in the cloud. So here, I don't want to make the same mistake. So we focused and we said Postgres only, cloud only, serverless only. So that was kind of the next big insight. Finally, what we're realizing now is, well, our user is a developer, and developers have lots of needs. We asked ourselves the question, why people use Neon versus AWS or Azure or GCP architecture. And the answer was always kind of like, oh, it's easy to use. You push a button and you get it. I think the real answer is that small teams that need to move fast don't have the luxury of having DevOps. And if you're using Amazon, you need DevOps, right? Because Amazon is infrastructure. Amazon is not a developer platform. When you use GitHub, you don't need DevOps, right? You as a developer consume that. It feels super native for you as a developer. But when you use EC2 or 200 services on AWS, you feel like it's like Lego bricks on which you build your application, and it doesn't feel like this is built for developer as an end user consumption. So that aha moment was like, oh, this is what it means. Smaller teams can move faster because they don't have DevOps, and they consume this directly. Once that clicked, we're realizing that those teams need more than just a database. And if you tune in to Neon, you will find that there's more and more technology we'll be shipping that is more on a database plus more that we'll be shipping.
One of the interesting points that you brought up is that Aurora had a lot of interesting capabilities and functionality of being able to provide this serverless experience, scale to infinity. You don't have to worry about provisioning the number or type of instances. You just throw data in and it does what it's supposed to do. The problem that I've seen, though, is that it is not an exact actual Postgres or an exact MySQL. There are enough edge cases that if you are using it for anything even remotely non-standard, you're going to hit problems, and you can't just use it as a complete drop-in replacement for MySQL or Postgres. And so your insight of saying that if you're going to do this right, it has to actually be Postgres through and through, I think is very salient and very well thought through. And so given the fact that Postgres is a very large and diverse ecosystem, a lot of different use cases that it's supporting, a massive number of different plugin types. I'm wondering if you can talk to some of the ways that you're thinking about what it means to be serverless for such a diverse ecosystem. What are some of the ways that you're trying to scope the applicability of Neon so that you don't have people coming to you and complaining that, oh, it doesn't do X, Y, or Z because I'm trying to use these 15 different plugins, and some of the ways that you're orienting towards that developer experience by removing the operational concerns?
Well, I think there are two questions in one here. One is, how do you maintain compatibility with Postgres in the where the reality is that the ecosystem is so deep? So what are you changing with Postgres and what are you not changing? And what are the net effect of those changes with regard to compatibility with the ecosystem? And like I said earlier in the call, the compatibility with Postgres is like paramount. And if you break it, you're on an island, right? At SQL Server, we used to say 99% compatibility means 99% of your customers have problems. So the compatibility needs to be 100%. So from the architecture standpoint, and you can look at the architecture of Neon in our documentation, we don't hide the fact that we actually run Postgres, right? We run Postgres in the VM, and we attach that Postgres into custom-built storage. And that thing we built from scratch. So the integration point with Postgres with our storage goes on a relatively thin API. At the end of the day, Postgres storage engine requests pages from disk and then write transaction log record, I'll call WAL, on disk. and then use wall to update those pages both on disk and in memory. And that's precisely where we interjected. So we said, instead of writing a transaction log record on disk, send it over the network into our service. And then instead of requesting a page or reading a page from disk, read it from our service over an API call. And just as you see, that allows us to actually not change the engine. Now, the reality is, well, you still need to change the engine because, while this looks very, very good on paper, then devil is in the details, and then there isn't a pluggable storage engine support at Postgres. So we had to do a little bit of surgery. The important bit is the amount of that surgery is not huge, and that allows us to keep the compatibility. So that's how you attach Postgres to our storage. Now, what about the serverless bit? So the way serverless works is we run Postgres in a VM, and we change the size of that VM and add more memory and CPU to the VM based on the workload, and then remove memory and CPU from the VM if the workload doesn't require as much memory or CPU. So also on paper, that sounds wonderful and easy to do. Well, turned out that there's a lot going there. So we had to build a lot of the VM expertise internally at Neon to support that. We also thought about running compute nodes in containers. Well, they're not really isolated, and Postgres can be hacked or broken out of the process, which is not ideal. So we needed that security boundary. In addition to that, we wanted our VMs to be able to change hosts. And Postgres is a stateful system. Well, state lives in our remote storage, but even the connection to Postgres is stateful. You interact with Postgres by establishing a TCP connection. So if you move your container from one VM to another, you break that connection. VMs, you can actually live migrate, and even the TCP connection remains. So that was kind of the second reason for us to use VMs. And now there's a ton of VM expertise because we run hundreds of thousands of them all at the same time on our platform. So basically the answer, how do you deal with the massive ecosystem of Postgres, is, well, through that architecture, we don't break app compatibility because the engine itself is still Postgres. It's just with swapping out storage from under Postgres, and the API to storage is so small that it doesn't impact app compatibility. So developers don't suffer, but do they thrive? That's another question. So, and what are the things that developers need to thrive? Well, some of the stuff is silly. You go and launch an RDS instance. It's not connected to the internet. And if you run Cloudflare workers, it's a gigantic pain to connect your application to the database. Certain things don't support TCP connections. So that's why we launched our serverless driver. Postgres doesn't do very well with lots of connections. And therefore, there are systems like poolers or PG Bouncer that allows you to scale number of connections to Postgres. So part of the value is just packaging all of that and make it stupid simple to consume, never run out of connections, and never do operations that you have to do with other systems, adding infrastructure to just the core database. But then there's more than that. Every application that a modern small team does, right? Bigger teams, they have DevOps teams, SREs, they stand up their own CI/CD pipelines. But if you're taking things off the shelf, if you're taking GitHub, if you're storing your front end on Vercel, if you're running your software development lifecycle by sending PRs and run tests in GitHub Actions, turns out database doesn't play nice in that. And we made it play nice. So we have database previews, which is achieved through the technology we call branching. We have the ability to create those previews based on every PR in GitHub. And now we're adding more and more features that would integrate with a deeper JavaScript ecosystem. So when you build apps and you need systems like auth or payments or storage, that's also trivial to do on Neon. So all of that kind of falls under the umbrella that you want to ship your applications faster. That's really the whole acceleration movement, which is mostly driven by AI. But really, by developer productivity, you can crank those apps much faster now. And for that, infrastructure needs to support them. That all of that contributed to the vision of that we have at Neon.
In terms of the engineering that you had to do on Postgres, as you said, Postgres is known for being very pluggable, but the storage engine, at least to date, has not been one of those plug-in interfaces, though my understanding is that that is changing. Wondering how you have had to approach the rework of that Postgres engine to minimize the footprint of your changes while maximizing the capabilities that you're enabling, and some of the ways that the scope and goals of your work on Postgres and Neon have changed from when you first came up with this vision of what you wanted to build to where you are today, where you have a real world production system that people are using every day.
That's honestly is not the hardest part. The specific work that's happening on the Postgres engine is whatever we can push into the extension, we pushed into the extension, and then the rest we forked, right? And the way we forked it is we know that this is going to make it into the core product, either in this form or once the pluggable storage engines will be introduced. And the amount of changes that we need in the core engine are so small that it's trivial to merge them as the new version of Postgres shows up. So I don't know if it's going to be Postgres 18 or 19, but by that time, I don't think we're going to have any differences between Postgres 19 and Postgres that we run on the platform. And all of that will go into the pluggable storage or extension API. I think the more interesting question is like, where do we spend time? Like, where is the innovation? And the innovation is at the bottom, what lives from under Postgres. That enormous amount of work that we did by building our storage subsystem that is fully elastic, multi-tenant, integrates with S3. We can run it globally around the world. That's kind of a marvel. The size of that project is similar to that of like maybe Pure Storage. It would be a comparative for us, except for Pure Storage is an appliance and we're a cloud service. And then another piece of work is above the database. So not only we made it serverless via that VM technology, but we also put a very nice developer veneer on top. And that goes into, first it's serverless, second consumable from HTTP. Now it's pluggable into like Next.js, all this like modern JavaScript framework, supports software development lifecycle, integrates with Vercel. There's like thousands of people using our Vercel integration and connecting database previews with Vercel previews, and the stuff that is coming down the pipe around authentication, around storage, around payments, kind of like more of a backend as a service platform, not just the database. And I think that's the right direction for us. While the database itself is very, very valuable, I think fundamentally we're delivering a shorter cycle speed to developers. And our slogan is ship faster with Postgres. So that's why we have to take over more of the app to allow our users to ship faster. And that's where a lot of innovation is coming into.
On that note of the branching capabilities, obviously that maps more closely to the ways that developers think about developing and deploying and debugging features. How has that capability being pushed into the database changed the way that development teams approach their iteration cycles and the ways that they think about actually managing their workflows and debugging capabilities?
I think it all starts with a specific pain. So let's start with the pain. What's the pain? Today, if you run a production system and you want to stand up a staging environment, you need to move data from the production system into the staging environment. I'm not even talking about how fresh this data is. I'm just talking about, give me a snapshot as of, I don't know, yesterday or today, a few hours ago. Give me the snapshot of that data in my staging environment. Well, it turned out, for whichever reason, it's a hard problem. Like, it's not that easy to do. Now I have my staging environment, but I'm sharing that staging environment with my whole team. Let's say my team is tens of people, maybe hundreds of people. They all need a staging environment, and they all change in schema because they're building the app. Now they're conflicting on both the resources, but then the other centralized resource is just the state of that database. So you can't have but if you want to have a staging environment on a per developer, and God forbid they also test in performance, now you have hundreds of copies of that. Not only hard to manage, it's also inefficient from the cost standpoint. Now imagine an alternative thing. Let's just say it's trivial to create a staging environment by creating a branch of the production environment. From there, you may or may not, small teams don't, but larger teams definitely do, mask or override all the PII data. But then once you have that staging environment, how can you have developers, create developer environments without breaking the bank? So each developer environment shouldn't cost you very much. And then, but still allow you to run performance tests if you want. And then the other one is, how do you, as you develop features and they all conflict on the database schema, how do you make sure that you resolve those conflicts? And this whole thing plugs into your CI/CD pipeline. The fundamental primitive that we have is database previews, which we call branches today, but we actually changed in that language. We're going to call it previews everywhere. And when you create a preview, it gives you a full copy of your data and schema, and then it's isolated. So for developer, it's yours. Underneath, storage does this smart copy and write thing, where creating a copy is zero write, so it's very quick. And then compute is just separate, right? So it's a different VM that runs Postgres, and that's your compute. So that's the definition of separation of storage and compute, and taking advantage of that architecture here. Now, in your developer environment, you can do whatever you want. You can change data, you can change schema, you can test performance, you can drop indexes, create whatever. But then you want to roll these things forward into first staging environment and then eventually production environment. What we've discovered is that people don't really care about the changes in data. As a matter of fact, the data changes in the dev environment should not propagate it all the way to the production. But the application depends on the schema. So schema has to migrate forward. There are lots of tools that help you with schema migrations. Those are called ORMs. Things like Prisma, like Drizzle, TypeORM, and whatnot. And we're just plugging into that workflow. So we're thinking very hard both of what is our place under the sun and what we should grab from the ecosystem and be orthogonal to that. So ORMs run migrations within the context of one database, but certainly it's not in their power to generate database previews and give you this fancy forking capability. So that's on us. But then we package it all such that it's trivial to set up the software development pipeline and lifecycle, where for every feature, you go to staging, create your development branch. If you want to create one every single time, you can just refresh your dev branch from whatever is the current thing in staging. Maybe you want to mid-staging, just do it directly from production, which is totally fine as well. Develop your feature, send a PR, and from that point on, we got it. So that really speeds up the cycle, to be honest. And we kind of super excited to see our customers taking full advantage of that technology.
With the separation of compute and storage, you're creating another hop for that data to flow. And I'm wondering some of the ways that you are thinking about the impact on latency, the impact on reliability, and the ways that you're engineering around that problem to get the best of a fully integrated stack of Postgres where it's all running in one unit, but the scalability and in terms of both compute and storage and pricing of being able to actually separate those tiers and the additional layers that you've had to work in to be able to mitigate those latency or performance impacts?
This is a very fair question. The important thing to understand is that if you run a highly available environment with your classical deployment, when you have 2 or 3 nodes, there is a network hop there anyway. So when you write into the master node to the primary node, the transaction is then over a network hop sent to a replica, And those are quote unquote synchronous replicas. So that write needs to be acknowledged by the replica, and only then you can acknowledge the transaction that you sent to the primary. So there is in a highly available environment, the hop is already there. If you run Postgres on an EBS node, well, EBS node is network attached as well. So we're not really, actually we do, but like at the high level, it's roughly the same number of hops. While the reality, there's a Paxos protocol that we use for reliability when we send the log record into our service that's called safekeepers. So that have multiple hops to persist the record in the Paxos protocol. But it's not like you can avoid network hops altogether. In some other architecture, you can't. The latencies fundamentally becoming, the latencies and throughput are becoming roughly the same. And roughly there's still a bit of a haircut that we're taking on latencies. But in return, we're giving you infinite IO throughput, right? Because our storage is multi-tenant and we can request as many pages as you want. So that's the trade-off, and specifically works super well for much larger databases. And for small databases, performance usually is not a problem. So that's the answer for the question of, so how do you deal with a network hop? Are you strictly worse? And the answer is, well, not really. You have those network hops anyway.
Another aspect of Postgres from an operational perspective that anybody who has run it for long enough has gotten bitten by is the upgrade process, where you have to deploy the new node, but you have to keep the old version around to be able to do the upgrade of the storage engine. And it's always this complicated dance. And I'm wondering how you're thinking about removing that pain for the end user and some of the ways that you, as a platform operator, are addressing the automation and scalability of that upgrade cycle.
As coming from SQL Server, and it's been 15 years since I left SQL Server, the fact that it doesn't have online upgrades bewilders me. And the way the upgrade process is set up in vanilla Postgres is frankly strange. SQL Server, you just restart. You shut down the old binary, start a new binary, point at the data location, and then it just upgrades on the spot in place. And the SQL Server team makes sure that the upgrades never fail. They just they kind of guarantee that this is the case. Here, you have to do a bunch of dance to upgrade a Postgres instance, but we just treat it as a feature. By the way, we don't have that feature yet, but this feature is under development. It's not difficult, but think about it. We run a cloud service. There is a playbook of how to upgrade vanilla Postgres. We apply that playbook for our instances. It's trivial to us to stand up a particular version of Postgres in that micro VM that attaches to storage. Of course, you need to do a bunch of manipulations so that storage is in the right format so you can attach to the next version. Yeah, it's a feature. We'll build it. It's not there yet.
And also, from the fact that you are focusing on the developer community, how much does version factor into their end user experience of, oh, I want to run Postgres? Is it, okay, well, which version do you want? Or is it just, okay, here's the latest and we'll make sure you stay on the latest?
We debated that. We let people choose the version, the Postgres version. Today, I was actually advocating to not. I was saying, let's just run the latest version and upgrade ourselves. But then we didn't have the upgrade feature for a while, and we still don't have it. It's coming. So we landed somewhere in between. So when the new Postgres version shows up, the default Postgres that we spin up is the latest version. We don't upgrade automatically, and we'll let people choose up to two versions back. And so far, the architecture of our storage allows us to do that. Again, it's a testament to kind of the level where we plugged in. So we plugged in at the page level, and pages don't care about the version. So that all works. I think there are benefits to just being on the latest version. I just lost that argument when we were introducing that feature. But we haven't been bitten by that much. And we haven't been bitten by this much is because Postgres is fairly disciplined and regimented in how it releases. It releases once a year. Not that much stuff changes. Developers, for the most part, don't care as much about this being in this version or that version. Every now and then some good developer features like JSON show up, and developers care about those. Otherwise, it's like Linux, right? Linux kind of works, this version or that version. Only the operator really cares, but the end user doesn't care as much.
On that note of developer-focused features, the topic that has sucked all the oxygen out of the room for everything else in tech is AI and generative models. Commensurate with that is the rise of vector databases. Postgres has the PG vector extension. As somebody who is running a platform as a service for Postgres, what are some of the ways that you're thinking about the utility, the messaging around, and the impact on your business of PG Vector and the ways that it incorporates with the Postgres ecosystem?
Oh, it's been huge. We're actually contributing to PJ Vector. There's a nice story there. Keiki, I think, is the number 2 contributor, still much smaller than the creator of PJ Vector, Andrew Kane, but nonetheless number 2 contributor. We found a way to improve PG Vector a year ago, and we realized that there's, this index called HNSW. We thought it should be in PG Vector. We didn't have a way to contribute to it. And then we built an alternative extension to BPG embedding that demonstrated material improvements for the IVF flat implementation of the index that PG Vector had. Well, still has it. Now you can choose. Once we showed the science, Andrew started to work on HNSW and introduced HNSW into PG Vector. He's done a great job. And that basically prompted us to retire PG embedding. And we took all our knowledge that we've collected by building PG embedding and what was applicable, we contributed back to PG Vector. So that was our experience from the business perspective. Oh, it's wonderful. It's wonderful that this thing is there. We obviously support it. We're contributors. We do things also. Our architecture makes it better to run PG Vector on Neon versus other platforms. And specifically, when Neon builds an index, and this is a very heavy compute operations because you do a lot of this vector math as you create that index. So super compute heavy, super memory heavy as well. Neon can temporarily give you more compute and memory on demand, and then shrink it back down. So you don't need to commit to very large instances ahead of time when you use PG Vector. So that was great. People build AI apps. Each AI app needs stuff, right? One of the biggest things, what makes an AI app an AI app, you talk to an LLM. Well, that's not us. But when you build a RAG application, you do need a vector database, and then the rest of the application chooses Postgres anyway. So that's what we do with Neon. And so far, that's been working great for us. I think there's going to be more and more demands, and especially as we add more developer features to the platform, in addition to just the database, we'll see more demand of having AI relevant features. We have a bunch in the pipeline, and we'll be announcing them kind of soon.
Another element that we've touched on throughout is the fact that everything you're building is being released as open source and permissively licensed. I'm wondering how you think about the relationship between the open source code and your business model and the overall sustainability of both.
So we're exposed to hyperscalers. I don't think we're exposed to anybody else. So in order for you to run a service like Neon, you need to have several pieces of the expertise. One is, well, you need to understand what's written in the code. It's very scary to run somebody else's systems code. And if for an operational database, if there is a bug, you need to fix the bug. So you need to build that expertise. You also need to, stand it up, set up all the observability, upgrade systems, basically set up processes that allow you to run it well. And then you need to build a team of committers that touches every part of the stack. So for a startup, next to impossible. For a large company like Amazon, Microsoft, Google, it is possible. It's also possible to build this whole thing from scratch for Amazon, Microsoft, and Google, and Amazon has already done it with Aurora. Microsoft is a little behind, and that's why we are actually partnering with Microsoft. And then, tune into some announcements. And then Google has a project called AlloyDB, which I think just behind Neon with the stuff that we can do. So I don't know. It is possible to quote unquote steal it, but only a handful of companies actually can. In the US, it's Amazon, Google, and Microsoft, and we partnered with Microsoft, and Google and Amazon have already done it. So I think we're good.
As you mentioned, your previous company was another database company. I'm wondering, what are the lessons that you learned in the process of building and growing Single Store, previously known as MemSQL, that have been most useful to you in the work that you're doing on Neon?
The first one is focus, right? We did too much at Single Store. It's a north of $100 million run rate business. So like we didn't fail, but we didn't take it public yet. And it's been some time. So, and if you kind of zoom on the reason, is we did too much. We were on prem when we were in the cloud. We were supporting operational workloads and analytical workloads, and the problems were different in each one, and shared nothing architecture, either both for analytics and operational workloads, breaks compatibility with the mothership. For us, the mothership was MySQL. We didn't use MySQL code because it's GPL, but we used MySQL protocol and syntax. And then turned out all the subtle bugs and the compatibility is something that I have a lot of scars on. So we certainly fixing that with Neon. We're not breaking compatibility. And then on the analytics side, cloud and object stores was something that we ignored for a while and then eventually caught up, but that was kind of too late. So I think the big one is focus, and then driving very, very hard towards becoming the default. And maybe that will take some time, but for the outside observers, and then later for customers and partners, it's very, very clear where you're going. And we want to become the default development platform for Postgres, and therefore our architecture, marketing. So if you do all the top line right, your technology is very, very solid. Your positioning is very, very solid. Your developer experience is solid. Your design is solid. Bottom line, what kind of follows, and that's our intention. So I think at Single Store, we had a lot. Well, I personally had a lot more energy. I lived in the office and slept next to the servers, but I didn't. I lacked that maturity and focus, which I'm bringing it here at Neon.
In the work that you're doing on Neon and the ways that you're seeing people use it for their own use cases, what are some of the most interesting or innovative or unexpected ways that you're seeing Neon used?
The stuff that we didn't expect is, and people do it a lot, is to using one database, one instance per tenant. They're like, well, they're kind of cheap. They stand up in 2200 milliseconds. I'm just going to run a full blown database service for full Postgres for one user. And we didn't expect that. Now there's like companies, they run fleets of instances. And it works actually really well if you have uneven consumption on a per client basis. If you have a long tail of customers, they barely use it. Okay, well, you're basically paying zero for those with Neon. And then some using quite a bit. And for that, you need elastic compute. So it allows you to kind of right size your usage very well. The second thing that we didn't expect at all is that people run what if scenarios with our branching capability. They're like, okay, every customer that is exploring, and that is specific financial planning product, they're exploring the impact of certain changes. Oh, well, we'll create a branch and then go hog wild on the branch, change data, reads, writes, whatever, and then compute the final result. That gives you an answer if what if scenario is successful or not. And then successful, you proceed. If not, you throw out the branch. That was another unexpected thing that I didn't even know that scenario existed. The rise of our serverless driver was another surprise to me. It turned out JavaScript developers don't know what a connection is and what a socket is. And I think it's great, actually. Like, nobody needs to know. So JavaScript engineers consume Neon using our serverless driver that allows you to query Neon over HTTP. That was another interesting surprise. What else? Yeah, those are probably the three most interesting ones. PG Vector caught us by surprise as well. Very quickly as we launched Neon, people are like, "Do you have PG Vector?" And so that became kind of standard.
And in your experience of building the Neon product, scaling the business, what are the most interesting or unexpected or challenging lessons that you've learned in the process?
I think we'll learn to automate a lot here. So we actually don't scale anything with people. We scaling everything is scaled by technology. So, for example, there's a feed on my Slack for new customers upgrades. People start with the free tier. When they upgrade, I get a notification on the feed. Everything is there's telemetry on everything, and then there's a data team that is very busy producing dashboards for us. Um, we make the decisions based on data, and we think about the world as kind of like this real estate. And we know we have good products, so we just need to claim that real estate in the world and then measure everything. So that I think was also a difference between operationally running Neon versus running single store. Also, Neon's fully remote. That allows us to tap into unbelievable talent around the world at the cost of the communication overhead. So I still don't know which one I like better. It's very fun to go to offsites and then like meet the team and then all these people who do incredible work and then seeing them in person. And at the same time, you do pay the communication overhead for people working from home. So yeah, those are the learnings.
As you were talking about the data that you're collecting, the dashboards that you're building, obviously to run a business, you need a database. It makes sense that you would use Neon internally as well. What are the cases where you're actually not using Neon and you need to turn to a different data engine?
We have two more data engines, at least, maybe more. One is powering our Grafana dashboards. And for observability, you need an observability engine. And then we use Snowflake for all the reporting. We are at 60 terabytes of data in Snowflake, and this number is shocking me. Like, how come Tiny Neon generated so much data? But we are where we are. Postgres is just not good for that. It's interesting that there's more and more work going into Postgres to support data and analytics scenario. It's going to be a while until it's going to be like a full-fledged data warehouse. But think about it. Postgres is like Linux. It's a commoditization force. And a vectorized column store query processor is a feature at the end of the day. SQL Server and Oracle have those. So we'll have them in Postgres too. And that's coming. And integration with the data lakes is coming as well. There's already plugins that people discuss on Hacker News that provide such functionality that allow you to query Parquet. And in the future, it's going to be Iceberg integration, Delta Parquet integration. So all of that is coming to the platform. Where it stands today, though, for analytics, it's good for small scale. It's not very good for large scale. And for that, we use Snowflake.
The cases where Postgres is not the right choice is something that many people have already discussed in various contexts. But for the case where Postgres is the right choice, when is Neon not the right way to run Postgres?
There is the meme going around where I just use Postgres. And I think it's great for us. I think it's great for the industry. Again, I think the era of lots and lots of database engines that are built for purpose is coming to an end. And you certainly still need, a data warehouse or a data lake, and history will tell if actually all you need is a data lake or you need a data warehouse as a data lake. We'll see. And then you need an operational database. So that's Postgres. Then there's like all the other things that you potentially need as well. I think over time, they will all go one way or another, meaning they will either be part of the data warehouse or they will be part of an operational database. If operational databases and an analytical database is going to be one, that I don't know. I tried with Single Store, and again, we scaled this post $100 million in run rate. I don't think we had enough of an industry impact to say you just need one. Maybe one day. But I still don't know, even, after 12 years of single store, I don't know if it's the 10 years out or 20 years out. It's certainly not 2, 3, 4 years out. Because not only you need to build technology, you need to change how people build software. And that's like a tall order. So I would say don't use Postgres for large-scale analytics today. And don't use a data warehouse to power your operational apps for OLTP. In between, you can decide, which way it goes. If you have something in between, everything else kind of will be pulled into one of those two.
And as you continue to invest in Neon, what are some of the things you have planned for the near to medium term, or any projects or problem areas you're excited to explore further?
Oh, there's a ton. So more clouds for sure. So I think we want to be the default Postgres offering everywhere in the world. And we're going to launch another cloud this year. So I'm super excited about that. That's one. We're going to add more developer features. We're going to make it much easier to build auth payments in storage and manage auth payments in storage with Neon. And we'll do it with some partners. So super excited about that as well. We're going to launch a GitHub app, which will make a much tighter integration for you with CI/CD and automatic creating of previews. We're going to start bridging some of this, not replacing, but integrating Neon with the data lakes. So that's another super exciting part. And then we're going to launch more platforms, meaning it's not our platforms, but other platforms that use Neon as the default database provider. So yeah, that's a lot. So I'm excited to pull all of that off and then launch well with high production quality. So I'm looking forward to all that.
Are there any other aspects of the Neon project and the business that you're building around it, or the Postgres ecosystem, that we didn't discuss yet that you would like to cover before we close out the show?
One thing that is not obvious to everybody is how actually a few people move the Postgres project forward. And there are a certain amount of aging that's happening in the core contributors to Postgres. So I think what would be very useful for the industry, not just for us, and we are contributing in a small way. We have a Postgres team and Neon engineers contributing to the core Postgres project, even in places where not kind of obvious how that benefits Neon outside of just like, well, Postgres gets better. So we do some of that work, and Heikki continues some of that work, and he reviews patches. I think the industry should train more people who are Postgres kernel engineers because of that aging problem. And the absolutely top contributors to the Postgres engine are now in their 50s and 60s. So it would be nice if more systems engineers from around the world, younger system engineers, started to contribute to Postgres. This is call for engineers and also call for the industry to sponsor this work. And the best way to sponsor this work is if you have a high dependency on Postgres, if you're running lots of Postgres instances in production, it's not that expensive for the big business to have some of those engineers contribute to the Postgres kernel.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you and your team are doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Well, can I talk about AI?
Absolutely.
I think, well, we stood up a data team at Neon, and even for a small company like ours, it wasn't easy. I think there should be an AI data engineer that can kind of like put it all together for you. And describing that problem in a very broad way, because I don't want to lead to the answer, right? This is definitely not text to SQL. Text to SQL is like a tiny piece of that problem. The problem is I don't have a data practice. I stand up this thing and that thing figures out and stands up the data practice for me and acts like a human. And that's tricky. But I think it's possible because now we see these systems like Devin from Cognition Labs. You see all this like AI engineer type work. We see magic.dev, like, and stuff that people are showing is quite magical. So you're like, okay, well, it's coming. I think that's one of the things that the data management is missing. You can go further. You can say, well, a data warehouse is that gigantic calculator, right? And it's a gigantic calculator, but in order to take advantage of that calculator, you need to like really organize data, put it into tables, columns, obsess about the schema, understand this has a semantic meaning to it. But imagine a gigantic brain that you can just like shove data in, and that thing makes sense of that data and then answers business questions. So I don't know what this means to the future of data warehouses if that thing existed. Now, again, I'm like thinking a little bit far ahead on this. But if we dream a little bit, then we may find unusually different architectures for data and analytics that are fully AI driven, and not just AI on top of a data warehouse, but maybe changing the architecture of the whole data warehouse. But we'll see.
It's definitely a very interesting future that I'll be excited to see how it develops. So thank you very much for taking the time today to join me, share the work that you and your team are putting into the Neon project. It's a very exciting project, a very exciting product. So I'm excited to see the ways that it continues to develop. Thank you again for all of the time and effort that you're all putting into that, and I hope you enjoy the rest of your day.
100%. Thank you so much.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.